Okay, week 29, our last installment in learning about trig identity. So here, this week, we're learning about solving trig equations, and we're basically taking what we know about the unit circle and applying it to different situations. So, first example says, solve sine of theta equals 1/2. Well, I think you already know this, right? We're looking for the angle whose sine is equal to 1/2, so we can say the inverse sine or the arc sine of 1/2 equals our answer. So if we type this into the calculator or Desmos, it will tell us 30 degrees or pi over 6 radians, but there is more to it. So we know that the sine of the angle is 1/2, and if we consider our unit circle like this, so we know that the sine is the y-coordinate, so we're thinking about this point. Notice how that has a value of about 1/2. So there are two angles that actually have that y-coordinate. We have over here this pi over 6, and over here this 5 pi over 6. If we were talking about degrees, this would be 30 degrees, and this would be 150 degrees. So you could type in your calculator, what's the sine of 150, and it'll tell you 0.5. And you can type in your calculator what's the sine of 30, and it will tell you 0.5, and that's correct. So we know that the angle starts from here, right, and goes around. So theoretically, there are an infinite number of answers to this question because the angle can keep spinning around. So we could have 30 degrees, but we could also have 30 plus 360. We could also have 30 plus 720, etc. So what I have written down here is a more correct way of showing the answer. So for our first, and this is in radians, we say that theta is equal to pi over 6 plus any number of 2 pi radians. So we could add 2 pi, 4 pi, 6 pi, 8 pi, etc. So 2 pi times k, where k is basically any integer. And that's implied. You just write the k, and we know that you mean 2 pi, 4 pi, 6 pi, etc. So we add that to pi over 6, and the same holds true for this, 5 pi over 6. So 5 pi over 6 plus 2 pi over k. So this right here, and I actually should have, if you're writing this, put the pi over 6 in front. It doesn't really matter, but so this, we say this is a list of all possible solutions to this equation, which is that the sine of the angle equals 1/2. And there are an infinite number, and they obey these rules. Okay. So, we started with that, and we're getting a little more sophisticated now. So, similar type situation. And I put in these different types of directions here. So it might say find all solutions, which is what we just did up here. And it might say find all the solutions where theta is between 0 and 2 pi, meaning just once around the circle, what angles have a cosine that is negative root 2 over 2. So here is our equation. Solve cosine of theta equals negative root 2 over 2. So we know that this is going to be one of those 45, 45, 90 triangles, and we have this type of situation. So 45, 45, and this is 3 pi over 4, and that would be 5 pi over 4. Notice how the cosine is the x-coordinate, and it's negative, so it's off to the left. So we would have this angle, and this angle being the angles whose cosine is negative pi over 2. Negative root 2 over 2. That's what I meant to say. Alright, so what we can say is that we have 3 pi over 4 plus 2 pi k. So this is our value of theta, and we have 5 pi over 4 plus 2 pi k. So again, you could have that angle, and you could also go around again, meaning add another 2 pi. You could go around again, add another 4 pi, etc. So that is our answer for find all solutions. And then let's take a look. We'll color code here. find all solutions between 0 and 2 pi. So that would be this type of situation. We go there, alright, so that's one answer. And then here, and then by the time we get to 2 pi we're done, and that's as much as we will rotate. So we could say theta equals, and it would be 3 pi over 4, comma, 5 pi over 4. Only those two values. Sometimes a question will ask you between pi and negative pi, in which case this angle would have been a negative 3/4 pi. Okay, sounds good. What do we have? Alright, so it says find all solutions to the equation. Same situation, only we have a little bit of algebra to do. So we're presented with this, and after a couple steps, right, we add 1 to both sides, we divide both sides by 2, we end up with this, and that's what we just looked at. Sine of theta equals 1/2, and so we know that our answer to that would be pi over 6 plus 2 pi k, or 5 pi over 6 plus 2 pi k. So a couple algebra steps. But basically what you're trying to do, you know, we used to try to isolate the x, and now you're just trying to isolate the trig function, get that all by itself on one side. Same for the tangent, so tan squared minus 3 equals 0. So we add 3 to both sides, and then we're going to take the square root, and remember if you take the square root you get this plus or minus. Aha! So we have the tangent of theta is equal to either positive root 3 or negative root 3. Now, seems like people tend to forget this tangent stuff. And I know that originally with the unit circle I did go through this. You can just find sine over cosine, but a tangent drawn to the circle, so we have this value as root 3 over 3, this value is 1, and this value as positive root 3, and then it's negatives on the other sides. So if we had an angle like, let's see, what are we talking about? Oh, root 3, okay. So let's say we were talking about this angle, and I'll get a bigger pen. So we have that angle, which is pi over 3, alright, and if we went around the circle, this angle has the same tangent. So if they're in a straight line, so this one was 4 pi over 3. Both of these angles have a tangent that is positive root 3. And then for the negative root 3, we'll use a different color. We could have this angle, which is 2 pi over 3, and we could have this angle, which would be 5 pi over 3. Both of those would have a tangent that is negative square root 3. So if this isn't in your head, I strongly recommend you write this down, get that in your notes, that will be useful. So let's see if we can apply this information to this. Let's see, I said oops, looks like I made a mistake. So tangent of the angle is plus or minus square root 3, so we have, let's see, pi over 3, but look at this, instead of, so just out of habit I wrote plus the 2 pi k, it's actually just 1 pi k, because every half time around, so here's pi over 3, and by the time we get over here, well, that has the same tangent, and by the time we get here, that has the same tangent, and by the time we get here, that has the same tangent. That's right. So for the tangent stuff, it's basically just going to be plus pi k. The sine and cosine will normally be the 2 pi k. We might have some crazy situation with a 2 in there, but maybe not. Alright, so this angle gives us a pi over 3 plus pi k, and then this one down here, 5 pi over 3 plus pi k. So this is all possible solutions, and we did a couple little algebra steps at the beginning. Yeah. Okay, and then lastly, so this says this, find all solutions, and you see this and you say, ay caramba, we have a squared. But this is just like 2x squared minus 7x plus 3. So you definitely know how to do this, right? Quadratic, we would factor, and this would tell us that this thing, we set it equal to 0, which gives us this, and this thing, we set it equal to 0, which would give us this. Okay, so we can apply that same reasoning to this trig equation. It's kind of cool when we're doing trig equations and we're factoring. Yep. So we would factor just like this, and we would do a little algebra right here. So we'd say plus 1, and then we would divide by 2, and we'd get this, and that looks like something we can solve. And over here we would add 3, and we'd get this. Now, cosine theta equals 3. Let's take a look at the unit circle. So here's our unit circle. It's called the unit circle because the radius is 1, and our cosine is the x-coordinate. So where on the x-axis would it be equal to 3? Never. Alright, so this is no solution to this part. So no solution. And so negative 1 cosine theta, positive 1. So this is if we talk about the domain of a function, okay? So the value of cosine of theta will always be between negative 1 and positive 1. Okay, so this is no solution there. The domain would be the angle. Sorry about that. So cosine equals 1/2. Let's see, here's our unit circle, and we're thinking. So our x value is 1/2, and we know that this angle is pi over 3 plus 2 pi k, right? And then this other one is 5/3 pi plus 2 pi k. Both of these have a cosine that is positive 1/2. Alright, so we would have this and that as our solution for list all the possible solutions after having factored. Okay, so that's our introduction to solving trig equations. We'll get a little more practice in notes part 2, but I think that will start you off well. Thanks for listening.